As we conclude our session today, we thought it might be important to do a little philosophical discussion of why confocal microscopy is important. Yes, we are doing fluorescence microscopy. A confocal microscope is a fluorescent microscope. But it's different from a standard fluorescent microscope because it can do what we call optical thin sectioning. Because of the pinholes in the microscope, the one after the illuminator that we can control and the one inside the microscope that is fixed, we're able to throw away light that is extraneous and not useful to us in producing an image. We're actually doing optical thin sectioning of our tissues by throwing away all the extra light above and all the extra light below the actual region of interest that we're interested in studying. So this is a very powerful instrument in terms of being able to do optical sectioning, high resolution images. Now the benefit to you as a researcher is that you can use thick tissues. In fact, one of our workers here in the lab is examining roach brains. And so that person can put an entire roach brain, a very thick section of tissue, on the microscope. And because of the optical sectioning capability, we can section all the way through the brain and make Z-stacks like we previously showed you. So you can use thick tissues. So specimen preparation is made easier by allowing you to use thicker tissues. Another very important benefit of the confocal microscope is that we're doing live cell analysis. Yes, you can do live cell analysis on a fluorescent microscope, but with the optical sectioning on a confocal microscope, you are now looking at individual molecules being excited by the laser and the fluorophore that's attached to them in real time in a living cell. So it's a very powerful instrument for doing live cell imaging in real time. The lasers are important. Why? The lasers allow you to illuminate your specimen with one single wavelength. And so you can select specific fluorophores, and new fluorophores are being manufactured all the time. So by selecting an individual wavelength with the laser, we can target and illuminate only that fluorophore that we know we're interested in seeing. Another important benefit, of course, is the time-lapse capability. You can do time-lapse on a regular microscope, but because we are doing optical sectioning with the time-lapse in conjunction with that, you can see these molecules moving around in a single plane in real time over time. We can also do the Z-stack as we showed you previously and build a three-dimensional representation of your tissue that you can manipulate in 3D space. Finally, when it comes to publication, as you know, having the most compelling images available is very important. And so the confocal microscope is no stranger to compelling images. Often your research publications appear to be more robust when you have these kind of images available to show. Well, we want to thank you for the attention that you've paid, for the time that you invested in watching these videos. We're looking forward to seeing you in the microscopy lab. We want to certainly thank the Keck Foundation, which has very generously donated not only the money for the instrument, but the money to produce this set of videos which you're learning from. We also want to thank Nikon Microscopy University for their support in allowing us to use some of the images at the beginning of the set of videos. We also want to extend our grateful thanks to Dr. Maria Elena Zavala, Dr. Paul Wilson, who are members of the biology department here at CSUN and who've been incredibly supportive in the production of this video. We also thank our videographer and expert filmmaker, Brian Smith, and finally our assistant, Deborah Liz Beltran, who did a lot of the behind the scenes work that you didn't get to see, but you saw the result of. So this is Mark Armitage thanking you and signing off from the biology department at California State University, Northridge. The last second take of the day, okay?